Wow, we got people from the Congo all the way to Australia with us tonight. Unbelievable. So how do you decrease equipment failures? By following a few simple steps. I've contemplated this thought for quite a while, trying to think about how can I put it in simple terms so people can go back and do something different. And that's what I'm trying to do today. So how do you know you're reactive maintenance? I guess it's a good question. How do you know if you're reactive? And you hear things like, we need to write a new PM. Equipment keeps failing. We need to write a new PM. Who worked on the equipment last? Nobody knows. It's a mystery. I think it was Jimmy. We never had parts in the storeroom. We never have a parts in the store. We never had them to begin with. Or maybe we did, but they were gone last week, and we had new ones in, and then they left pretty quick. We know we reactive maintenance when we do that. When we do not have time for training, we got too many problems. I hear that too often. I can't send my people to training. We got too many problems. Really? Maybe training might help you solve some of those problems. We have a problem with technician morale. Yeah, I was in a plant recently. Technician morale was so bad. And here I was doing training with the technicians. So I had to turn it around and give them a positive look at it. Technicians are really the foundation for our reliability program. We have to keep their morale up, not by giving them more money or anything else, just thanking them for the job they do. We cannot afford to hire a maintenance planner. Heard that one last week too. Think about this. I've got maintenance technicians that are running around like crazy, fighting fires, and I have no planner, so you'll never get out of reactive maintenance until you have a maintenance planner. Why don't you take your best maintenance technician and make them a planner? I've seen places do that, and it really turns them around fast. Our storeroom never has parts. Yep. So we never have parts in a storeroom, but we keep going back again and again. We just don't see it. And we do not need a maintenance planner. We just need our people to step up. I don't know how many times I've heard that. What does that mean, step up? Maybe it's, this lack of morale has something to do with reactive maintenance. But I guess when we have a failure, we have to know what constitutes a failure. So equipment failure refers to any event in which any equipment cannot accomplish its intended purpose or task. It also means that may also mean that the equipment stopped working, is not performing as desired, or it's not meeting target expectations. Two types of equipment failures I see it: total functional failure and partial functional failure. Okay, I see we got a couple of reliability engineers on. What would you consider a type of failure? Would you consider a total functional failure is what your plants normally look at, or do they also capture partial functional failures? I know you guys are sitting quiet in the audience, so I know you're there. Put it in the chat if you don't mind.
Can you restate the question, Ricky?
Question is, how do you measure failures? Do you measure by total functional failure or partial functional failure? How do you measure it? Got one said we just start measuring failures, capturing failures. Yeah. Both. Okay, good, Jeremy. Thank you. Hesman, total, yeah. So, I mean, we have different ways of looking at it, right? But both depend, yeah. How do we detect the failure? Absolutely. Okay, good. Thank you. So what are primary causes of equipment failure? Let's get to the root of it. A lot of equipment failures have to do with maintenance being reactive. And it's like an alcoholic. You got to admit that you drink alcohol. So it requires admitting we have a problem. Okay. So if we're reactive, if we're gonna stop the failures, we have to get out of the reactivity we're in right now. Improper operation. Most failures, I'm talking about partial functional failures and total functional failure, I think, and many times are created by operators, operator error. And I don't understand it because their job's not that difficult. Failure to perform corrective or preventive maintenance to specifications. When I talk about performing corrective or preventive maintenance to specifications, I get the deer in the headlight look with a lot of people. It's like specifications. And the reason they give me that is because they don't even know what the specifications are. So when they install a pump, they install a V-belt, install an electrical device, they don't even know what good looks like. And that's sad. It really is. Doing too much preventive maintenance. I don't know how many places I've seen, they've got so many PMs they can't get to them. And when you really dive down into it, you find that every time they've had in the past, over the last 20, 30 years, they've had serious problems. Somebody writes a new PM and it adds into the system and it doesn't work. You can't do that. We need preventive maintenance, but we got to understand what is preventive maintenance for and how do we do it effectively and correctly. That's a big deal. Ineffective or no predictive maintenance application to critical assets. I had one company today on, some training with me, and they don't do any predictive maintenance, but all the rest of them were doing a lot of predictive maintenance. Just do it on critical assets. If you're not doing it at all, just start there. You don't have to do it in-house. Hire a contractor outside to start with. I don't want it in-house until I can prove the concept. Then I want to bring it in-house. We do it ourselves because predictive maintenance is a great tool to mitigate failures over the long run. Maintenance planning and scheduling is dysfunctional. Wrench time is low. Absolutely, no doubt. It's all a reason why we have it. If you don't have planning and scheduling, here's the deal. So when you're talking about no planning and scheduling, that means you're reactive. You're just going out when somebody gives a trouble call, you send someone out and they go out and try to fix the problem, whatever that means. So they patch it. A few days later, that same problem comes up again. That's not what we want. What we want through preventive maintenance and predictive maintenance, the information that comes from them, we plan it, we schedule it, we execute it to specifications, and we have specifications on the procedures that we follow. And our wrench time should go up, but in order to do that, to make it effective, we need to have a maintenance planner. Take your best maintenance technician and make him a planner. One that can use a computer, okay? No scorecard dashboards, ensure everyone knows their score in their specific position. We got to know how we're going to play this game. If any of you watch football or soccer or rugby, whatever, with no scorecard, no scoreboard, the players won't play. That's the same thing in maintenance. We need to have scoreboards. We need to have dashboards. We need to have those scorecards up for people to see them. How well are we doing, good or bad? If it's bad, then we need to talk about it. When I was a maintenance manager, one of the things I did, I had every morning before we started with all the crews, we looked at that dashboard. We knew our score in the game. We knew where we needed to focus on. And it didn't affect, it wasn't impacting everybody right away, but ultimately everybody felt like they were part of that team to make sure we got to where we needed to go to. Roles and responsibilities aren't clearly defined. How do you know? When you hear statements like, that's not my job, or, hey, don't call me when you got a problem with that. That's not acceptable. Roles and responsibility. I'll be willing to bet you reliability engineers here, you'll use for everything but reliability engineers in a lot of cases. I know Honda, I know you guys do it pretty daggum good, but a lot of them, they have reliability engineers, but they just get sucked into this reactivity, and we got to stop it. Wrench time's low. Hands-on tool time is low. So what is wrench time? It's the percentage of time a maintenance person has their hands on a tool. And it's called wrench time. Okay. So we look at world-class wrench times, 55 to 65%. It can't be 100%. Some people say, my guy's 100%. Yeah, but that's not what I'm talking about. Okay. Typical wrench time is between 15 and 25%. Worse than class wrench time is 5 to 10%. That's what a lot of companies are right there. You have to admit you got a problem in order to solve the problem. I'd say But world-class wrench time, when I'm talking about, when someone says 100%, think about breaks, think about travel time to and from job site, think about looking for parts, looking for tools. There's a lot of things that take away from wrench time. And so if we want to get better, we got to know where we are. Wrench time is a big deal. It's a big deal. Root causes of maintenance being in a reactive state, lack of proactive maintenance knowledge or experience. We don't know what we don't know. I mean, we may have smart people that know some of it, but the whole organization needs to understand proactive maintenance. They need to understand it. That's the whole reason I created toolbox talks, to help people understand, to gain the knowledge so they can make changes in it. Toolbox talk is just a single point lesson. In case you don't know what I'm talking about, it's a single point lessons I've created over the years that just get frustrated. When I go to a place and I see a problem, I create a single point lesson, and it's there for one reason only, and that's to give people knowledge. So hopefully they can see hope. Lack of knowledgeable leadership and maintenance best practices. It's not just overall, but I mean, our lack of knowledge for leadership. And just one place I was at not too long ago, the only one that understood proactive maintenance was the president of the company. I couldn't get it. I mean, how does he know it? Nobody else knows it. It must be a secret. That must be what it is. That's right. So production and maintenance. I want leadership on both sides to understand what maintenance best practices are. The environment is in the organization reactive. Everybody knows it. However, no one knows how to move out of it. It's like any journey, you got to take one step, but you need to take the step in the right direction. You better have a map to say, and where I'm at right now, I got to know where I am on the earth. Take that map, look at it, take my GPS out, which is my CMMS, and start navigating through it. Everyone knows maintenance costs is out of control, but they're not certain what to do about it. How do you solve that? And you can't cut your way to it. A lot of companies, they just start cutting costs. Cutting costs doesn't do any good. Why don't we reallocate the money to the right place? That's what we need to do. So we have a metric. Okay, the metrics maintenance cost is the percent of replacement asset value. This came from Alcoa Mount Holly, where I worked many years ago. Maintenance cost is the replacement asset value, typical 3.5 to 9%, world-class 2 to 3%. It's all about the money. It isn't about driving cost out. It's by doing the right thing. It's by doing things the right way. That's when you bring costs down. And this is all costs, okay? That's the labor, materials, contract maintenance, everything. Then maintenance materials cost is the replacement asset value. So you notice typical is 1 to 3.5%. Look at this for world class, 0.25 to 0.75%. Wow. So replacement asset value, what SMRP says is the amount of money it would take to replace the facility, brand new, everything like new. I'm just being generic about it, okay? But so if I would have destroyed a plant and built a brand new and run on top of the same site, what would it cost? So what would that replacement cost be in today's dollars? Well, it's not realistic. The number I go for with companies that want to know where they are, set a baseline of where they are, is we go after what is the insured value. We just start with that. That's a good number. We're not trying to figure out how we're better than somebody else. All we want to know is let's set a baseline, and if from that baseline, determine how well we're doing and how are we getting better or not. So number 2 cause, improper operator error. Some of the root causes of it, error. Lack of leadership, lack of discipline. Everybody's kind of doing their own thing. Lack of training. Believe it or not, operators, many times, they're hired off the street, they're put into a role, but they have not been trained. It doesn't make sense. I mean, the best thing you can do, they need to go through some written training, some classroom training, and then they need to go through training with coaching, somebody coaching them. That should be their supervisor. No operator care program integration with the maintenance PM program. Why don't we integrate? Why don't we work together? Why is a maintenance person going out looking at something? The operator's there anyway. I like putting targets up. So a technician, like what I used to do with my technicians, they had every technician had a route every day in the morning, first thing for the first hour, and they walked through certain areas of the plant, and we had numbers up, 1, 2, 3. You look at your chart on your clipboard, and you look at it, bump, 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 and it tells you what to write down. Okay, what do you see? And it's very simple. Lack of a scorecard is seen and accurate. So I just put together an operator care leading and lagging KPIs. What are the number of abnormalities identified? What's the number of less than 6-minute stops? Kind of sounds like OE, right? Percentage of time line running to rate. What's the percent of first pass quality? Then operator care, what's their backlog? Do they have a backlog? And in some cases, there's some companies that do have backlog for operators to do things. Okay. And then, so they have total backlog, ready to schedule. And that's what they do is they send that. So this is categorized in maintenance. They have the ready to schedule, and all that comes out to OEE. All right. So failure to perform corrective and preventive maintenance specifications, number 3, root causes of failure to perform corrective and preventive maintenance specifications, lack of knowledge of what best practices are and how to manage as a proactive organization, not a reactive one. Lack of resources. We don't have enough people. How do you get enough people in a maintenance organization? Some of you guys, somebody tell me that. Chat it in. How, if we don't have enough maintenance people, how do we get enough maintenance people? Or how do we increase wrench time? It's both the same question. You ever have enough time? Yeah. How do you have enough people? One is maintenance, planning, and scheduling. Start allocating your resources appropriately. I always had my people set up that we knew, and they knew who was going to be pulled off the job first. If we had everybody was scheduled by day, by hour. But we had certain people assigned. Okay, Jimmy, you're the first one. You get the first call, you take care of it. Bobby, you got the second one. Sam, you got the third one, and so on. But all I want them to know that, but that doesn't mean people come to them. They come to me first, and then I'll allocate the people for resources, okay? So lack of resources, money, the right people, leadership from top to bottom. We got to have leadership, not just leadership at the top, but we need to have leaders as technicians too. Lack of training dollars. It's amazing to me how much money we spend. I spoke to this president of this company. We were talking about the money, and he says, Ricky, I got plenty of money for training. The problem is I got to spend it wisely, because I'm not going to spend money on training and not get something out of it. And that's the fact. That's a fact. Don't send someone to training that clearly the expectations are set forth so they understand what those are. Doing too much preventive maintenance, mentioned that earlier. Root causes of why you're doing too much preventive maintenance. What are they? No training in preventive maintenance. All knowledge has been passed down over the years. So tribal knowledge, it's just been passed down. So over time, we've learned from the past, but really what we've done is we've watered things down from what they were probably doing it great at one time. And if you ever been in a company, say, yeah, we used to do that. Yeah, we used to do that. Yeah, we used to do that. Yeah, I know. We need to get back to that. Okay. Not knowing how to perform preventive maintenance as a controlled experiment. I call preventive maintenance, should be performed and preventive as a controlled experiment, excuse me. So what that means is you put equipment in a controlled state, okay, maintainable state, and do certain things to it to give you the desired outcome. Okay, whether that's lubrication, whether that's time-based replacements, whatever that is, lubrication, we do certain things to it to give us a certain outcome. Equipment's not in a maintainable condition. If the equipment's not maintainable, you got to restore it. That doesn't mean you got to full-blown buy a new one or rebuild it totally from top to bottom, but we need to get it functioning. Remember those functional failures? We need to mitigate or eliminate those functional failures we're having with equipment. We're measuring the wrong thing. PM compliance. Okay, I got that, but that's more to me. That just says we did it. That's all. But my question is, did we do it the right way? Are we finding something from it? Used to be, when I worked at Alcoa, one of the things we said, our manager expected, John Day, he expected to see certain amount of work coming from preventive maintenance. If he didn't see it, then he's going to call somebody in his office, and I only went to his office one time. No one wants to go to his office, okay? Because it doesn't take long for the discussion to end. But why don't we find stuff with it? We need to know that, right? But to me, if I want to know if preventive maintenance is effective or not, I look at emergency labor hours. That's what I look at. And you notice this chart I've got, PM labor hours are steady, emergency labor hours decreasing. That's what I want to see. That's what I want to see. Then no one understands the PF curve. Where does preventive maintenance fit on the PF curve? So what is the PF curve? It's a graphical representation how something fails. It's fairly simple. Preventive maintenance starts way before point P. It starts way back, okay? If we don't want it to get to the functional failure, partial or total functional failure, then we need to do preventive maintenance correctly. So ineffective or no predictive maintenance application, what is that? So no one understands how to detect failure modes early enough. Maybe we're not, maybe one of the things we're not using predictive maintenance right. Maybe we're only using it to satisfy the insurance company regulations. What do they require? And we do that. We focus on the insurance company without regard to how much money we lose on a daily basis by not using predictive maintenance. We need to make predictive maintenance an integral part of our strategy to maintain the site. No one has ever heard of the PF curve, and I know most of the people on today, I know what the PF curve is. I think it, to me, it needs to be a thing that you have a talk with your people about what it is and how it works in the organization. But if we can detect defect or abnormality early enough, we can plan it and schedule it before it fails. So if we have a defect on an outboard bearing on a large horsepower motor, and it's a critical motor, I'm going to go ahead and plan that job. I may not schedule it yet, but I'm going to plan it because I know it's going to fail, because bearings fail randomly. So what I'm going to do is I'm going to identify that fault. I'm going to go ahead and plan that repair. And then when I have, if I can, I'm going to go ahead and schedule it. If I don't schedule it, here's the worst thing can happen. If I already planned it, and I got the spare parts, I got the procedure on the spare parts, okay, how to do it, then the worst thing can happen, if we do have a premature failure, no matter when it is, we got the procedure, we got the spare parts, and they're secure. So all we got to do is pull them out of wherever we've got them locked up at, and we can go out and do the work to specifications. So when production says, how long is it going to take? I probably have a good idea how long it's going to take. Okay. So maintenance planning and scheduling is dysfunctional. Root cause of dysfunctional maintenance planning and scheduling. Maintenance leadership has never been trained in maintenance planning and scheduling. When you talk to maintenance leadership, a lot of times they say, yeah, I know that stuff. Yeah, I know that. And they don't really understand it because they've never seen true proactive planning and scheduling. No one knows how bad the organization's wrench time is. If we're low, we probably need to get it up higher. And sometimes any direction we go, we might get something, but it's only luck. We don't want luck. We want facts, and we want to have direction. Maintenance planners are trained. However, no one's allowed to plan and schedule the right way. I've seen planners that go to training and come back and they're not allowed to plan and schedule. I know what you learned in the class. I know what you learned in the class, but we don't do it that way here. But then why'd you send me to training? Don't build expectations up if you're going to send me to training. Maintenance is reactive. The maintenance planner's chasing parts. My gosh. One of the things I always say, how do you know if you got a proactive planner? Call them on the phone and say, hey, I need a part right now. The next thing you should hear, if he's a proactive planner, is the dial tone, because evidently you called the wrong number. Okay. So some of the guiding principles that I say on this, maintenance planners focus on future work only. Okay. All, today's issues handled by the maintenance supervisor lead person. All work scheduled, which required parts and materials, are kitted in a secure area. All planned and scheduled work is tracked through status codes. See the status codes below, RTS, ready to schedule. The parts are kitted, they're in a locked, secure area, and it's ready to be scheduled. So the worst thing could happen if we have a failure and it's not on the schedule yet to do that repair, we already have the parts. We have the procedures. We don't have to worry about it. Another one, waiting on parts. You know, we need to know that. Awaiting production. They need to know that. We go into a production meeting, they need to know how much work is backed up, how many labor hours of maintenance work is backed up. All work scheduled 1 week in advance, typically scheduling meetings on a Thursday for the following week with production, maintenance, and others as required, could be contractor, safety, or whatever. I want, again, leading and lagging KPI for planning, scheduling, work execution process. You know, if we don't measure it, we can't manage it. And that causes a lot of problems. You know, next one, you know, no dashboards or scorecards to ensure everyone knows their score and the position. You know, root cause of no scorecards or dashboard. Leaders don't have time to identify how to create a maintenance scorecard or dashboard. No one knows how to create one. If leadership don't know it, no one else knows how to create it. We got a problem. Maintenance is data rich, but no one knows how to assimilate and disseminate, you know, the date, you know, to help everyone know the score and the position. So we need to assimilate the data, disseminate the data, and then share it with each position. So here's a scorecard: PM compliance 100%, 40% plan work, schedule compliance 100%, work order close out accurately 47%, rework 78%, and maintenance costs 12%. Now, to me, PM compliance is 100%, schedule compliance 100%, but our work orders aren't closed out accurately, and we got a lot of rework, and our maintenance cost is going up. I think we probably need to do a full-blown root cause analysis on that for sure. Roles and responsibilities aren't defined. Root cause of unclear roles and responsibilities. We got to have, you know, how do we manage what we're doing? Reactive plant culture, our roles and responsibilities are just, we come in and we do whatever we do. And the roles and responsibilities, you know, they just happen, whatever that is. But every day, roles and responsibilities could change. I like to have a RACI chart. A RACI chart across the top in position, you see, you got the positions across the top, like plant manager through CMMS administrator. Down the left side, we got the tasks, CMMS management. On each line, you can only have one A. You can have more than one R, more than one C, more than one I. But A is the buck stops here. So here, if CMMS is not managed properly, okay, then the CMMS administrator where the buck stops, because they control it. Okay, let's go all the way down to maintenance rework. Who's accountable? The maintenance manager. Let's see. I'm sorry, I didn't put any reliability engineers on this one. But you see it, what this does, if you bring all the stakeholders in the room and you identify the tasks that we have to, you know, work together on, and we identify our roles and responsibilities, we can clearly determine how we're going to work together more effectively and efficiently. So simple tips to result in a reduction in equipment failures: define what constitute a partial functional, and total functional failure. Hire someone to provide simple RCA training for the plant, production, maintenance leadership, maintenance technicians, operators. If you got maintenance engineers or reliability engineers, they're great ones to teach it because they know it and they know it well. Write work orders for all failures and ensure the following is identified: asset number, problem or work required, part used, you know, labor type, hours, number of techs, root cause of the failure. Root cause of the failure. So if we're writing a work order, if we don't know the root cause, how are we correcting the failure? Maybe we need to do an RCA first, right? We've got to know that. So LS, lack of specifications, OE, operator error. These are some of the root causes of failure, right? You know, not enough time to repair the specifications. We had to patch it. We got to go. Hurry up. How much longer is it going to take? No repeatable procedure. Okay. And whatever else you want to add to it. I think that's important to do that. Okay. Condition that's found. All right. Bear with me a second here. Sometimes I had to move my screens around. Condition as found, condition as left, recommended changes to the procedure. That's one of the things we need to have. You see this chart I've got it in front of you, right here, in front of you. So we've got at the top, job description. So this is lubricate bearings. The frequency is asset numbers there, line 1. Frequency, estimated labor hours is 1 person times 1 hour. Estimated production downtime is 0. Then we go next, the originator of it, the owner. The cautions go in yellow. Cautions have to do with equipment damage. Okay, so yellow, failure to follow PM requirements could result in equipment failures. We got parts if we need it. Okay, here we got synthetic lube. So in case, what this is for is when the planner is planning the job, if they need something out of the storeroom, it's already on the procedure. All they got to do is say, okay, I need to check that out, put it in the kitted area. So the maintenance people, when they get ready to do the work, it's already in the kitted area. Any consumables needed, lint-free towels, whatever that is. Special tools required, single pump grease gun with type 237 synthetic grease gun. Okay, so we went synthetic grease. Okay, any mobile equipment, none on this case. Required departmental coordination. Production lead will notify before execution. Will be notified before execution of lubrication. And here we have step by step. Now we have, the craft type. We have the number of craft hours, but I want in each step on this PM, I want initial. And it doesn't matter if it's a PM, a corrective maintenance procedure. I want initial beside each step. That way we don't skip a step. Because a lot of times people say, well, I've been doing this for 20 years. I know how to do it. Right. And that's why we got problems too. Okay. We need to start focusing in on putting initials by each step. That way, if we go back and we have a failure, I like to pull the work orders out that we've completed and look at those work orders, doing a root cause analysis, say what's going on. This tells us a lot. Condition is found. So how do they find the asset? Leak coming from number 1 gearbox. We need to know that. Condition is left. Cleaned up oil, notify production leader to keep area clean of oil. And we're probably going to have to write a work order for that to resolve that problem. Okay. So any comments? None. Craft feedback, all good. I want craft feedback on procedures. So the first time you write good procedures, I want to see something back saying it doesn't make sense. So if I put equipment history with this and I send it out with the procedure, then when technicians look at it, okay, and they look at the failure history for the last 30, 60, 90 days, they can match up, is this procedure make sense or not? Is it working? So more simple tips. Number 4, track and manage failures. Cost of failures, lost production. I like that. It's about the money. Parts, expedited cost. How much does it cost to air freight something in, overnight delivery, or I call a vendor in town and I say, hey, I need a part, real quick. So how bad do you really need? I need it real bad. Okay. So when they look at when they punch the number in what it costs, it's not going to be the normal value. It's going to be up. So you pay more money for the part. And then parts of material cost overall. What's going on there? All right. Create an A3 report to share failures with everyone. I know this is a crazy thought. This is just one of my crazy ideas, but I was at a plant and it just so happens they had a gearbox failure and production lost 330 units of production. Asset criticality is high. They should have caught the defect severity on it. So they lost 330 units, which 4 hours of downtime cost them $7,050. Okay. I like pictures to show the failures. Okay. So if the gearbox failed, I put pictures of the failed bearings on there. So we got the problem. So what was the root cause? Could be many factors. Okay. It could have been a perfect storm. Known gearbox noise, reported on daily checklist for 2 weeks. Production needed to run, could not take downtime to replace gearbox. That probably may or may not be the reason why it failed, but it could be. Okay. Resolution, replace gearbox to specification. I sent the gearbox out for rebuild and forensics. When I send a gearbox to some company that rebuilds the gearboxes, or if I send it in-house, what I want is a few things. I want to know forensic. I want them to tell me what they think the root cause of the failure was, why it failed. I want replaced the parts that were replaced in the gearbox. I want it to come back to me so I can lay it out for all the technicians to see. And what I used to do when I had a failure like that, I'd lay the parts out and give everybody one chance to come up with what they think the root cause of the problem was. And the one that got it right or close to it, then I'd buy them and their spouse dinner at whatever restaurant in town they want. We lived in a small town, okay? So it wasn't like there was a lot of fancy restaurants, okay? But still, it really got them moving. We want to review all PM and frequencies on the gearbox, review past oil sample results. So the cost of the gearbox was $200. The gearbox was $800. So let me think, $1,000 compared to $7,500. That's a lot of difference. So how are we going to measure sustainment? On this gearbox, PM compliance, 10% of the time frequency. And I want to do it on all critical assets. In other words, if it's a monthly PM, you got 3 days to do it and you're out of compliance. Oil sample, time from the sample taken to results received and reviewed, measured. If resample required 3 days of resample, if out of specs, corrective maintenance work order written, replacement planned and scheduled. Very simple. Create a dashboard to measure reduction or increase in failures by asset or area overall. PM compliance, 98%. My goal is 100%. Rework, my goal is 0. I don't want to have rework. Got 7 reworks, okay? We just got to know where we are in the game, okay? If any of you watch football or soccer, the score in the game is a big deal. So MTBF of critical assets, 11.4 hours. Goal, 342. We got a long way to go. The maintenance costs continue to go up. I like to trend it. I want people to see a line graph on it. It's the best way to do it. And the last one, so emergency labor hours, what is it doing? It's going up. It's trending up. We got a problem. Final thoughts. Okay. Keep your maintenance storeroom locked and secure 24 hours a day, 7 days a week. Ensure 90% plus of maintenance work is planned and scheduled. 2 different functions can be done by the same person, should be done by the same person, unless you've got a different type of organization, a very large one. Ensure 100% of scheduled work has repeatable procedures. If we're going to schedule the job, I want procedures that are repeatable. So if we have a failure, we take that procedure and we may have to change it to take that next step change to get out of those failures. State equipment failure, maintenance statement, equipment failures are unacceptable and must be eliminated unless run to failure is the maintenance strategy for a specific asset or asset. Run to failure is a maintenance strategy, but most companies that apply run to failure don't even know it's a maintenance strategy. It's just the way they run it. Train maintenance leadership and maintenance best practices. It's a big deal. We know that. You don't get a lot of time with them. I just say, what you need to do is just sit down with them, just make sure you've got your plan together, you got your thoughts together, put together a PowerPoint presentation with leadership. So all I need is 30 minutes, because you're not going to get much more than that, maybe an hour, maybe, with the plant leadership team. I tell you what, last week I had the maintenance technicians in the training, and it so happens the senior leadership of the company, I'm talking about the president, he showed up in the room. And I'll tell you what, he didn't leave. He loved it because he felt like maintenance leadership needs to hear this stuff. They need to understand it. Train all maintenance planners plus 1 technician in formal maintenance planning and scheduling, plus 1 technician. Because in case a planner's out, I need someone that can slide in and not be sitting there going, what do I do? I want them formally trained and they know how to do it. Provide formal training to 2 maintenance technicians in root cause analysis. If you got to send them off to training, do it. If you want to do it, if you're going to do root cause analysis in-house, bring a vendor in. I recommend you identify some of the problems you have so the class can solve the root cause. They can identify the root cause of the problems and solve the problems that you have in the training. That way you pay for the training. create a new position. All right, you reliability engineers have been waiting on this one, I know. Maintenance, just call or reliability engineer. I like maintenance engineer and technician because it doesn't threaten other technicians, but a maintenance engineer and technician is just your best maintenance tech, and they're focused on failure elimination and mitigation. That's all they're focused on. They're not chasing fires or anything else. They're out there to help me. If I'm a maintenance engineer, reliability engineer, they're my right-hand person that's going to help me get out of this ditch that I'm in right now. Then post a scorecard to provide all levels of plant personnel the status of the maintenance process. I want people to know, how well we're doing. If we're not doing good, that's okay. At least we know where we are, but don't need to hide stuff. We need to make sure we share it appropriately. All right. So questions. Here's my planning and scheduling class coming up in January 19th to 21. It's in person. At Southern Wesleyan University outside of Clemson, South Carolina, really central South Carolina. Most people gonna be on Zoom. So you get a Zoom link just like this. You just go to it. So for 3 days, it's on Zoom or live, whichever you want to do. So what are your questions now? How to measure schedule compliance during the week. Okay, so one of the questions was, how do you measure schedule compliance during the week? So every maintenance technician should be scheduled. If they're supposed to work 40 hours, they should be scheduled for 40 hours of work. And they should be scheduled by day, by hour. So Monday morning, they don't come out of the shop and say, okay, I got to look through these work orders, decide what to do. No, if it's 7 o'clock, the equipment, a line is expecting someone to come to replace a gearbox or something, then it should happen. That maintenance technician should be there at 7 o'clock, even if he comes in at 7 o'clock. What I had to do when I first started this, getting planning and scheduling, really going with my crew as maintenance supervisor, I had to bring my technicians in early. No one knew it but me. Okay, so I bring them in early so we get everything ready. So at 7 o'clock, the technicians are standing on the line. So we're waiting on them to shut down. That's what we agreed in the scheduling meeting last week, that on Monday morning, this equipment shut down at 7 o'clock, cooled down, cleaned up, ready to be worked on. If we don't, then that breaks, that's what they call a break to the schedule, which is a metric. How many breaks to the schedule? Okay, so you schedule people, all maintenance people based on priority of work, by day, by hour. It should happen. If you got people 7 days a week, all of them should be scheduled. Even think about it. I mean, I was a shift mechanic. Okay, I worked at Exxon. I was a shift mechanic. Okay, what my job was dealing with problems production may have, and deal with things that maybe make it through the next day. But when I didn't have that, I had PMs to do. So I always had PMs that weren't as critical as what day shift PMs were, but certain ones I could do on a night shift or an off shift. All right. So how do you present your MTBF for critical equipment during the week, month, if there's no breakdown? If no breakdown, I mean, there's no failure, right? If a breakdown is a failure, then it's not. All right. What else? Caitlin, you got the questions? Anybody? Can you see them?
You've done a great job asking them or reading them. How do you effectively measure wrench time on the day-to-day?
Really don't. The biggest thing to do is look at schedule compliance. If you're scheduling by hour, by day, then you could pretty well say that your wrench time is going to be high. I don't really care if what the number is. I just want to know I want to increase wrench time. And the only way you're going to increase wrench time is by planning and scheduling correctly. Planning and scheduling is the only way you're going to increase wrench time. Telling people to work harder, work faster, work smarter, it's not logical.
Got it. Is a partial failure considered a machine breakdown?
To me, a machine breakdown is a total functional failure. The machine's functionally failed, then no functions are working, so it's a total functional failure. Partial functional failure could be that, you've got a bearing failing and you can hear it. It's reducing the speed on the line, but could be a partial functional failure.
Perfect.
What else?
Are there any other questions for Ricky?
Come on now for Honda. I want to hear a Honda question.
Okay. I don't know if I understand the question, but maybe you will, Ricky. How do we measure stockout material 12 from the store?
Stockout it's very simple. It's the SMRP metric. When you go to the storeroom, the computer says it's in stock, and you go to it and it's not there. It's a stockout. It's not there. I got some bad news for you on that. If your plant's reactive, you're going to have a lot of stockouts. So measuring stockouts it isn't the root cause of the problem. The root cause is planning and scheduling because you're so reactive. And when I say if you don't have planning and scheduling working well, you start off with a small area, small part of the crew, plan and schedule for them. Like just start off with 2 technicians planning and scheduling. And then you start to grow it and grow it. You know, you can't start out and just say, I'm going to do it all at one time. All right. What else?
What would you recommend if the storeroom is not a closed storeroom and there is no place to locate kitted parts in a secured location?
So the question is back to the person, do they have an area where all the parts are right now in one area?
Armand, that's for you. Yes.
Okay. Just put a cage up. Put a cage up, you know, around a fence around it high enough that makes it difficult to climb over. Okay. You put concertina wire on top too. That works pretty good. You know, I'm ex-Army guy. Okay. I like that concertina wire. So you can do that. And then I would put, you got to lock it. Okay. You're going to have to lock it. Okay. We got technology now. We got these things called card readers, you know, so we can, when we go to the storeroom, we scan the badge. And then when we open the door, an alarm goes off. Womp, womp, womp. Why do we have an alarm? So you get in the door and close it behind you. Now, I want to have a system that tracks. You can do it. You can use your PLC to track this. Okay. How long did a person in there? All of you got some type of PLC. So why not track how long they've been in there? And then the next morning when you come in, you get a report saying, you know, Jimmy and Billy was in there. They didn't check out anything. Okay. So, you know, if it was at night shift, I call them at home and say, hey, you know, when they're sleeping, hey, Billy, Jimmy, what's going on, man? You're in the storeroom last night, so you didn't check out any parts. Oh, yeah, we forgot to. Yeah. This time is on me. Next time it's on you. Okay. You know, we want to have the parts secure. That's a lot of money in a company, not just in parts, but the parts that we need to put using that plant. All right. What's next?
That's it. That's all we've got. Thank you so much, Ricky.
Thank you.
Awesome. So if you would like to get a little more involved, please make sure to sign up for maintenance planning and scheduling with Ricky. His email is right there, rsmith@worldclassmaintenance.org. It's a three-day workshop in January. Ricky is also available through our Upkeep Connect platform. So that's upkeep.org/connect to be a one-on-one mentor for you and your maintenance organization. So if this workshop isn't something you're able to commit to, but you would like to be able to call on him and ask for one-on-one advice, check out upkeep.org/connect and see if regular mentoring is something you're interested in. Have a great rest of your day, and thank you, Ricky.
Thank you, everybody. Have a great evening. A great day wherever you're at. Bye.